So today what we're going to do is we're going to start the unit on functions. You have probably noticed that your code is getting a little wieldy and like out of control. It's getting really big. And your flowcharts are getting like really big and complex. And that's exactly what happened in history, okay? We started writing programs. They were small little things that did basic math for us in a loop with if statements. And then as things got more and more complex, they got bigger and bigger, and it's hard to keep track in your mind like what the heck is going on in these things. And if you're working in a group, it's even harder for you to keep track of your piece and also somebody else's piece and make sure that everything is working. So what they did is they came up with a way to now break our program into even smaller chunks. Okay, so if you remember way back into top-down design, we talked about input, process, output, but now our process is getting out of control. So we want to break that into smaller chunks. To help us program, not as just individuals, but as in a team, it turns out it's really useful to assign a chunk of code to somebody and a chunk of code to somebody else, and then bring those chunks together. Those chunks of code should be a logical grouping that does something. Okay? Whatever that somethingness is might be kind of vague, but does something. So you give the rules of whatever that thing is to somebody, they go off and code it, and they should arrive back with your chunk of code. It turns out that a function is a really good way to encapsulate that chunk of code, because maybe the thing we're giving to somebody actually could be useful in some other program. It turns out we have been using functions right from the get-go. Right from the very first day when we did the Hello World program, we were using a function. That print statement is a function. Okay? Somebody else wrote that. Not us, but somebody else wrote it. And as we saw in the last assignment where we were doing the looping thing, it actually can accept one parameter. You put it inside quotes, hello world, but there is optional things that it could accept. Remember, in Python, we had the ending and we assigned it to nothing so that it wouldn't put a carriage return. So somebody had to write that code. So we've been using functions from day one. We've also been writing our own functions from day one because we've been putting things in main. Okay? We have that weird if __ main is equal to main. Okay, it's called dunder main, technically in Python, that's what it's called. And if it is then true, then we hop into the if statement and we call the main function. And then we hop up and we write some code in main. So we've been doing this. We've always created a main function. Turns out we can write other functions. If you think back to when we did local and global variables, we had several functions there. So we're going to talk about and use more functions today. Okay, so a subroutine is sometimes referred to, or a function. All it is a block of code that is written for a specific task. Okay, a nice small chunk of code that you could see on a single screen, understand what it's supposed to do, follow the flow, and see what's happening. Okay, to make a function work, we need two separate mechanisms. We need a way to write a function, and we need a way to call the function. Okay? And hopefully when we call the function, it goes to the proper function. We might want more than one function, so we need to differentiate between different functions. Okay? So we need a way to call the function, and we need a way to actually execute the function. Since our programs are getting a little complex, here is a good template, which is usually what programmers do to keep track of their entire code in a single file. Okay? You always put a comment header at the top so we know who wrote it, when they wrote it, and what the heck this file is supposed to do. Okay? So super common. We've been doing this from the very beginning. If you have any global constants to the file, in Python we create a separate file. In C or other languages we just put it at the very top. Okay? If you happen to have any global variables, so something that does change but may be used in several functions, okay, then you would put it next. This is a really dangerous thing to have. if you have some variable that many different functions use, you might want to check what the heck you are doing, okay? It might be needed, but in reality, you should probably never be doing this, okay? And we're going to talk about why eventually, okay? Then you put the declaration of all your functions so that when someone looks at your code from the top down, they can see who wrote it. Here's a chunk of code as a function, here's a function, here's another function, and then you have the main body of your code that would refer to all of these functions. This is strictly for humans. The computer doesn't need the functions to show up before the main body of the code, normally, okay? Most programming languages, especially if they're compiled, because it can hop around, okay? Humans, it's really nice for us to see something before we actually start calling it, okay? Because you'll see a chunk of code with something that refers to a function, you're like, I've never even seen that thing. What the heck is this, okay? So this is usually the order that we place code in, okay? And we're going to follow this. So in Python, when we're going to call a function, you use the name of the function and you put brackets at the end. We're eventually going to put stuff in those brackets, but for now, they're just going to be empty. And we've already seen this when we've been calling main, okay? We've been doing this over and over again. Hopefully it's nothing new. It's just that we're going to sort of formalize what's really going on. So I'm just going to wait for my program to start here. There we go. Okay, so here we are in Python, and we have our shebang at the beginning, and then we have our comment. Remember, that's the first thing that should show up. I have no global variables or constants, and then I have this definition of this function called calculate area. So when Python reads this file in, since it's an interpreted language, it will go from the top down. When it hits this definition of a function, it's going to say, oh, I'm supposed to remember it. I'm not going to do it right now, but I'm just going to remember it. This is the thing that it's called, and this weirdness that we've been putting at the end, we're going to talk about that in a couple of days too, okay? So it's going to remember all this code, and it looks like something we've always seen before. Okay, we have an input. We're going to grab the input. We would probably put that in a try and catch, right? But just to keep things simple, I got the length and the width. I did a calculation, and I spit it back. Okay, so this is just a chunk of logical code that it remembers for whenever I need to call it. And it calculates area. Look, I gave it a really nice name so everybody understands what's going on. We have another one that calculates perimeter. Okay, so same kind of thing. We're going to ask for input. We do the calculation, and we print it back. And then we have our main function, and here is where we call it. So you'll notice this name here is identical to this name here. Okay. Once again, we put these round brackets. We're going to talk later about why they're here and what we can do with them. Okay. And then we have finally we have our dunder name, and we're checking, does it equal main? We know it's equal because that's an equal. Okay. And if it does, then we call the main function, which we have been doing. So you'll notice I have a breakpoint right here, and even more importantly right here. This will be the very first line of code that Python actually executes. So I'm just going to step through this. And here we are, and this variable does actually equal main, just like it always has for us. And it hops in, and it's going to go to the main function. Okay, so it should hop up to here, which it does. But now it's going to call this function, and it should hop up to the very top. So when we click step 1, look, we've hopped all the way up here. Notice what's happening in our local and global variables. Okay, so we don't actually have any global variables. So all these variables will come under local. So this length right here is going to be a local variable. So we're just going to input something, let's say 12. And notice our local variable inside the function gets created. Now we're going to enter in width, and it gets created. Okay, I'm just going to move these down so we can see what's going on. Now we're going to create area, and we're going to multiply the two numbers together. Okay, that makes sense. Then we're going to print it out, so it should show up down here. Good, it does. Now I'm just going to print one extra space. And now, notice I'm back here. Notice my local variables vanished. They are only local to the function. They were created in the function. They get used in the function. When the function is done, they get thrown back technically on the heap. That's where they go. Okay? So we no longer have access to them. Okay? They're gone. So now that it's done, it's going to go to the next line. And now it's going to go to the next function called create perimeter. Okay? Notice this variable here is called the exact same thing as here. But they are two separate variables, two separate memory locations. This thing doesn't exist anymore. It's totally gone. Okay? So we're going to enter in another length. I'm going to put in 42 this, 43. Okay? So it's recreated. Now we're going to create width. Now it's going to create perimeter. It does the calculation. It's going to print it out. Just a space. Notice they're gone again. As soon as you leave the function, they are gone. You can never access them again. Okay? The memory is released, given back. The computer can do something else with it. Once it's done here, it's going to hop down, printer done, and now it's going to finish main, and our program's going to end. Okay? So that's the workflow on how functions hop around, and also why the heck we need a debugger so we can keep track of what the heck is going on. So then you use the name of the function to call the function, just like we've been doing up till now.